In this video, we're going to take a look at log transformations. So our parent function is y equals log base b of x. So I've written them all out in different colors according to each different transformation. So in purple, if we have a negative in the front of our whole function, it'll reflect over the x-axis, just like we've talked about before. If the value of a, we call it, is right in front of log, it makes it have a vertical stretch if the absolute value of a is greater than 1, and a vertical shrink if the absolute value of a is between 0 and 1, like 1/2. If we have a number in the parentheses that we're taking log of and it is added to x, then it makes it go to the left that many units. And if it's subtracted, it makes it go to the right that many units. If there's a number added or subtracted out behind the grouping symbol, it makes the graph shift up or down, and it's what it looks like. So if it's adding k, it will go up that amount, and if it's subtracting k, it would go down that amount. And then the last transformation to make a note of is if there is a negative in front of the x that's in this parentheses or in this group, or we're taking log of it, that is a negative, it would make it reflect over the y-axis. So let's look at a couple examples. So the first 3 examples I wrote out are just one transformation occurred, and then we'll look at a few combined together. So for example 1, we have y equals log base b of x plus 4. So this graph just shifts up 4 units. That's all that happened to that one. In example 2, we have a negative out front, and then we have log base b of x equals y. So the negative out front just made this one reflect over the x-axis. That's all that happened to this function. And then on number 3, we have f of x equals log base 3 of x minus 1. And the minus 1 is in the grouping symbol, so that makes it look like opposite of what we normally think would happen. It would go to the right 1 unit. Alright, so the next 2 examples have a couple transformations in one problem. So the first only had one thing happening. These have more than one thing that happened. So in example 4, y equals negative log base 5 of x plus 3. So the negative in the front would make it reflect over the x-axis. And then the 3, since it's in our grouping symbol, would make it go left 3. For example 5, I put f of x equals 1/2 log base 2 of x plus 4. So the 1/2 makes it have a vertical shrink or compression, either word is okay, by a factor of 1/2. And then the 4 is not in a grouping symbol, so this made it go up 4. So notice on all of these examples that the b, the base, the 3 right there, that's our base, the 5 is our base, and the 2 on this example is our base. Those numbers do not affect the transformation. They would affect whether the graph itself is increasing or decreasing, but they're not part of our transformation. Okay, look at example 6 and 7, the last 2. These have multiple transformations within one problem. So for g of x equals negative 1/2 log base 3 of x plus 2 minus 1, we had a lot of things happening. It reflected because of the negative out front over the x-axis. The 1/2 made it have a vertical shrink or compression by a factor of 1/2. The plus 2 is in grouping symbols, so that made it go left 2. And then the minus 1 is not in a grouping symbol, so that made it go down 1. So lots of things happened with that example. And then on number 7, the last example, I have h of x equals 5 log base 7 of negative x plus 8. So this 5 makes it have a vertical stretch or expansion by a factor of 5. Then the negative inside of this parentheses makes it reflect over the y-axis. And then the 8 is not in a grouping symbol, makes it go up 8 units. So that is it for some transformations of log functions.